Hey guys, so let's go ahead and get through the section 5 review. So as always, remember that the section number is next to the question. So if you want to go take a look at the notes or take a look at the homework for that section, you can. So number 1 says, what is the axisymmetry of the parabola? Now for the axisymmetry, remember that is a vertical line down the vertex. Okay, so the first thing we're going to need is the vertex for this parabola, which is -7, -3. So some vertex of -7, -3. And then it's not really necessary, but the parabola is opening down since the a value is less than 0. It's a negative number, so it is opening down. So just a quick rough sketch of that parabola. There we go. So the axisymmetry is a vertical line down that vertex. So it's a vertical line down the x value of the vertex, which the x value of the vertex is -7. So it's the vertical line x equals -7. Remember, it is a line, right? So you have to write it as the equation that represents that line. Moving right along, let's look at number 2. So on number 2, given the function y equals -2x squared plus 8x minus 11, we want to rewrite the function to show the maximum value. So the maximum value is actually the vertex, right? It's the y value of the vertex. So writing it as the maximum value, in other words, is just writing so that you can see the vertex. Okay, so write it in vertex form. So you can actually do this in one of two ways. You can either complete the square, or you can use the formula -b/2a to find the h of the vertex and then plug it in to find k. I think just completing the square is much easier, so I will do that. Remember, for completing the square, you need to group the first two terms, separate the back term. And what we want to do is factor out, because in order to use the formula for completing the square, right, is b/2 squared. That's how you figure out what number we need to add in order to complete the square. The coefficient of the x squared term has to be 1. So we have to factor out -2 from the first two. So 8 divided by -2 will be -4x. And then now that the coefficient of x is 1, of x squared is 1, now we can use this b value, -4, we want to divide that by 2 and then square it. So we got -2 squared, which would be 4. So that is the number that we add here, and that will make this a perfect square trinomial. Now that 4 that we added is not actually 4. It's 4 times what's on the outside of the parentheses, which is -2. So that's really a -8. So essentially, really what I did was subtract 8, right? Add a -8. So in order to balance that, I need to add a +8 on the back. So here we actually -8. So to balance, we're going to add 8 on the back. So now we just bring down the -2, and then we need a factor. X squared minus 4x plus 4 would be x minus 2 squared. -2 times -2 is 4. -2 plus -2 is -4. And then on the back, -11 plus 8 is -3. So that would be the vertex form, which shows the maximum value. The maximum value would be the y value of the vertex, so it would be -3. Okay, so there it is. This shows the maximum value. Rewrite the function, here it is, so that it shows the maximum value. Okay, let's move on to number 3. So on number 3, we need to find the vertex of the equation. Now we can actually do find the vertex form to find the vertex, because you can see the vertex right away, right? The vertex here is 2, -3. Or from standard form, you could use the formula to find the x value of the vertex, h, is -b/2a. Okay, so that's how you find the x value of the vertex, and then to find the y value of the vertex, you just plug in the x value, and that'll give you the y value. So let's go ahead and use the formula for h, -b, b is -8, over 2 times the a value. The a value is 1/4. So -8 is +8, 2 times 1/4 is 1/2. So we're doing 8 divided by 8 divided by 1/2. Dividing any number is the same thing as multiplying the reciprocal of the number, and the reciprocal, if we flip over 1/2, is 2 over 1, which is 2. So it's really 8 times 2, which is 16. Now that we have the x value of the vertex, we can go ahead and plug that in to find the y value. So let's go ahead and plug the x value into the function to find the y value. So y is 1/4 times 16 squared minus 8 times 16 plus 2. So 16 squared is 16 times 16, which is 196, I believe. 16 times 16 is 190, way off, 256. And then multiplied by 1/4 is the same thing as dividing the reciprocal 4, which is 64. Remember, whenever you are simplifying, we do exponents first, then multiply, right? So simplify the terms, multiply, do the exponents, and then multiply. So we ended up with 64. Then negative 8 times 16, well, 8 times 16 is 128, so that's negative 128. And then 64 minus 128 plus 2 would be negative 62. So that is the vertex. Okay. Then we can go ahead and move on to number 4. We want to express this in standard form. Remember, to get standard form, all we have to do is simplify. So all I need to do is go ahead and simplify this equation right here. So I have 2 copies of negative 2x plus 3 multiplied together. Remember that if you do not have just one term inside of the parentheses, you cannot distribute the power, guys. Okay, this is not 4x squared plus 9. No. Okay, 2 copies multiplied together. Let's go ahead and distribute. The negative 2x times negative 2x would be 4x squared. Negative 2x times 3 would be negative 6x. 3 times negative 2x would be negative 6x. And then 3 times 3 is 9. Bring down the minus 1, and then we can go ahead and combine like terms. 4x squared cannot be combined with anything. Negative 6x minus 6x is negative 12x. And then 9 minus 1 is 8. And that is the standard form. Remember, for standard form, all you do is simplify. Okay, let's move right along to number 5. So we need to find the intercepts of the following quadratic function. So if we're finding the intercepts, notice that they didn't specify x-intercept or y-intercept. That means we need to find all of the intercepts. We need to find both x and y-intercepts. Let's start with the x-intercepts. Remember, to find the x-intercept of any function, we're going to set the y value to equal 0 and then solve for x. So I'm going to go ahead and set this output y value to equal 0, and I need to go ahead and solve for x. Now, one of my first lines of defense to solve for a quadratic is to factor. So the first thing that you should always do is factor out a negative from all terms. So we have x squared minus, because 2x divided by negative 1 will be negative 2x, and then plus 5. So we need 2 numbers that will multiply to 5 and will add to negative 2. And the reason why it only multiplies to 5 is because the coefficient of x squared is 1, right? So we don't have to rainbow over. So multiplies to 5 is only 1 and 5, right? And no combination of 1 and 5 would ever add to negative 2. So we can't factor. So we're going to have to use the quadratic formula, okay? So the a value is 1. The b value is negative 2, and the c value is 5. So we're going to go ahead and use the quadratic formula. Negative b, negative 2 would be positive 2, plus minus the square root of b squared, which is negative 2 squared, minus 4 times the a value, 1, times the c value, 5. And this is all going over 2 times the a value, which is 1. Okay, simplifying by terms, let's go ahead and do negative 2 squared, which is 4. Negative 4 times 1 is negative 4, times 5 is negative 20. So that's minus 20. And 2 times 1 is 2. Simplifying further from there, actually, let me just go ahead and bring this up over here. We have 2 plus minus the square root of 4 minus 20 is negative 16 over 2. Now the square root of negative 16 is actually 4i, right? The square root of negative 1 is I, and then the square root of 16 is 4. So this is 2 over 2 plus minus 4i over 2. 2 divided by 2 is 1. 4i divided by 2 is 2i. So my 2 x-intercepts, they are not real. They are 2 imaginary x-intercepts, 1 plus 2i and 1 minus 2i. All right. Let's go ahead and move right along to doing the y-intercepts for this graph. Actually, this is a function, right? It's a quadratic function, so we will only have one y-intercept. So let's go ahead and find the y-intercept. For finding the y-intercept, we're going to set x to be 0 and then solve for y. So we're going to go ahead and find f of 0. So we're going to input 0 into my function. Okay, and we have to be very careful, right? Exponents first, so 0 squared is 0. So we have negative 0 plus 0, 2 times 0 is 0, minus 5. Now negative 0 plus 0 is 0, 0 minus 5 is negative 5. So my y-intercept is negative 5. You can write just the number itself, or you can, of course, write it as an ordered pair. All right, moving right along to number 6. On number 6, we're going to need to graph this equation. The graph of this equation is the image of this equation. So what transformation has happened? So this is your pre-image. This is the before, or the original equation. And this is the after. This is the image, or the, what you get as a result. So notice that we have just a simple shift, right? Before we were to the left 5 units, and then we're now to the right 3 units. So if we had went from the left 5 to now being on the right 3, that's a total of minus 8 in the equation, which is shifting horizontally to the right 8 units. And that's because it's a minus 8 on the equation itself, right? But remember, everything with x is the opposite, so it's actually a shift to the right. And then with the y value, notice we went from being up 6 to now being up only 2. So we actually subtracted 4. So that means if we were up 6 and then now we're only up 2, that means we had to go down 4. So that would be a vertical shift down 4. Okay, moving on to number 7. So we need to go ahead and describe the transformation of this function, g of x, which is related to the graph of f of x. So we're writing what happened to this function from just a regular old parent quadratic function. So notice that, remember, horizontal we list first. So on the inside to the x value, we subtract the 2. Now remember, x is opposite. So if we see minus 2, we are actually adding 2. So that means that we are shifting to the right 2 units. And that is a horizontal shift, of course, because it's happening to x. Then we need to move on to what's happening to the y value. Now on the y value, I see multiplying a negative 1 and also adding 7. So if we multiply the y value on the outside of the parentheses, right? So it's happening in the y value. We're multiplying the y value by a negative. That is going to change the sign of the y value, which is a reflection over the x-axis. After that, we need to add 7 to the y value. So that will be a vertical shift up 7. Remember, everything with x is the opposite, but y is exactly as you see it. All right, let's move on to number 8. So on number 8, we need to consider the system of equations, and they're asking where is f of x equal to g of x. So let's go ahead and set f of x to equal g of x. We need to find where do the two functions meet. So I'm going to set this y value equal to this y value, and that will give me the solution to the system. So to solve this system, I'm going to go ahead and first get equals 0, because I do see this is going to be a quadratic equation. So I need equals 0 in order to solve. So I'm going to subtract x and subtract 5. So that'll give me 0 on the right-hand side. Negative 3x minus 1x is negative 4x. And 10 minus 5 is 5. Now I need two numbers, if I want to solve this by factoring, that multiply to 5 and will add to negative 4. Now the only things that will multiply to 5 would be negative 1 times negative 5 or positive 1 times positive 5. If I add those two, they will give me negative 6 or positive 6, not negative 4. So I can't use the quadratic, or I can't factor for this either, which means that I will need to use the quadratic formula. So to use the quadratic formula, I'm going to go ahead and A is 1, B is negative 4, C is 5. And my quadratic formula is negative b, negative negative 4 is positive 4, plus minus the square root of that b value squared minus 4 times the a value times the c value. This is all going over 2 times the a value. Simplifying from here, we need to simplify by terms. So negative 4 squared is 16. Negative 4 times 1 times 5 is negative 20. And then in the denominator, 2 times 1 is 2. Now if I simplify in here, 16 minus 20 is actually negative 4. So this is 4 plus minus the square root of negative 4 over 2. And the square root of negative 4 is 2i, right? The square root of 4 is 2, and then the square root of the negative 1 is I. So I have 4 over 2 plus minus 2i over 2. 4 divided by 2 is 2. 2i divided by 2 is 1i. So those are my two x values. Now remember, this is a system, right? So I have ordered pair solutions. 2 plus I is one x value. 2 minus I is the second x value. So I need to now figure out what is the y value that matches with that. To figure out the y value, all I have to do is plug in the x value into one of these two equations. One of them is clearly much easier, right? The linear is way, way easier. So let's go ahead and plug it into there. So y equals 2 plus minus I plus 5, because that's your x value, right? And plus minus I can't combine with 2, but I can combine 2 and 5 together, and that'll give me 7. So I end up with a y value of 7 plus minus I. So your plus 7 plus I came from inputting 2 plus I. So the y value for 2 plus I is 7 plus I. And then the y value for 2 minus I will be the 7 minus I. You can write your answer like this, or you can also write it as a combined ordered pair. 2 plus minus I goes along with 7 plus minus I. The plus solution goes along with the plus solution. Top goes with top. And then the minus goes with the minus on the bottom. Bottom goes with bottom. So you could write it either way. All right. Let's move on to number 9. Now, number 9, we need to determine if this function has a minimum or a maximum, and then state what is that value. So the way that you figure out if it's a minimum or a maximum, first you have to look at what kind of function is this. This is quadratic, right? So it's a parabola. Now, is it an upward-facing parabola or a downward-facing parabola? Well, the a value is negative. If the a value is negative, it's a downward-facing parabola. So it will for sure have a maximum, right? Not a minimum. It'll be a maximum. Now I just need to figure out what is that maximum value. The maximum value will be the y value of the vertex. So I need to figure out what is the y value of the vertex. I could do this multiple ways. I could either get the vertex form so I could see the vertex, or I could use the formula h equals negative b over 2a to find the x value of the vertex and then plug it in to find the y value. That's what I'm going to do. So negative b over 2 times the a value will be negative 6 divided by negative 4, which if we simplify would be 3 over 2. Now let's plug that in to find the y value. If we plug that in, we got negative 2 times 3 over 2 squared plus 6 times 3 over 2 minus 2. And I taught you guys this in class, but you can actually use your calculator to type all of this in. Okay, so we can plug in negative 2 and then open parentheses, a fraction, 3 in the numerator, click down so you could go to the denominator, 2, go to the right to get out of the fraction, close the parentheses, power of 2. Go to the right to get out of the power, and then we need to add 6 times, open parentheses, we need a fraction, 3 is in the numerator, go down to the denominator, 2 is the denominator, go to the right to get out of the fraction, close the parentheses, minus 2. We hit enter and we get 5 over 2. Of course, alternatively, you could just do the calculation by hand, but this speeds up the process. So the y value, right, the vertex is at 3 over 2, comma, 5 over 2. The the maximum is that y value. So the maximum is the y value 5 over 2, and it's located at that vertex point 3 over 2, comma, 5 over 2. Technically, you don't need to say where it's located at, just the fact that the maximum, I keep saying minimum, is 5 over 2. All right, let's move right along to number 10. So on number 10, we need to express the quadratic function in standard form. Okay, So there's a lot going on here. The first thing that I want to do actually is I could see that I have one term here, one term here, and one term here. So what I can actually do is I can multiply both sides by 6 just to get rid of the fractions. That way I don't have to deal with the fractions, right? So I get 6y equals, and then 6 times this term would be 6 divided by 6, so that'll cancel. Then 6 times this term, 6 divided by 3 will be 2, so it'll be your numerator times 2. And then 6 times this term, 6 divided by 2 is 3, so it'll be your numerator, negative 3x, times 6 divided by 2, which is 3. Now let's go ahead and simplify. So we need 2 times 1, which is 2. And negative 3x times 3 will be negative 9x. We also are going to need to multiply these 3 things together, right? Negative 1 times this, also times this. So we need to multiply one thing at a time. Let's first distribute the negative 1, so we get negative x plus 7. And we need to multiply that with x plus 2. So now we can go ahead and multiply negative x times x is negative x squared. Negative x times 2 is negative 2x. 7 times x is 7x, and 7 times 2 is 14. Bring down your positive 2 and bring down your negative 9x. Bring down your left side, 6y. From there, let's go ahead and combine like terms. Negative x squared we can't combine with anything, but we can combine negative 2x plus 7x is 5x, and 5x minus 9x is negative 4x. Lastly, 14 plus 2 is 16. On the left-hand side, bring down your 6y. Now, obviously, this is almost standard form. We just need to get y but completely by itself, right? So the last step here is just to divide everything by 6. So we get our final standard form, y equals negative 1/6 x squared minus, simplify the fraction, 2/3 x, simplify the fraction by dividing 2 on top and bottom, 8/3. All right. Let's go ahead and move on to number 11. So on number 11, we need to write a quadratic function that passes through this point, has an axis of symmetry of x equals negative 3, and a minimum value of 7. Now this is actually kind of a trick question because they give you the vertex right away. You might not think that they give you the vertex, but they give you the x value of the vertex. How do I know that? Well, the axis of symmetry, right, is a vertical line down the x value of the vertex. So that means that the x value of the vertex, if this is the line x equals negative 3, the x value of the vertex is negative 3. And then this is a quadratic function, right? So it's a parabola. And if it has a minimum value, that means that this parabola is facing up. And the minimum value is the y value of the vertex. So they gave you the y value of the vertex as well as 7. So this is a parabola that is facing up with a vertex at negative 3, 7. Now we have another point. This is a random point, x, y, right? That is at negative 1, 9. Now, I can write any quadratic function that I want, which means that I could write it either in vertex form, I could write it in standard form, I could write it in factored form, in any form that I want. But the easiest is going to be vertex form since they already gave me the vertex, okay? So I'm going to go ahead and find the a value of the vertex. Because remember, the vertex form is y equals a times x minus h squared plus k. So in order to fill in the vertex form and write the vertex form, I just need a, h, and k. I'm already 2/3 of the way there because I already have h and I already have k. So all I need to do is solve for a. So I'm going to go ahead and plug in this random y value into my vertex form, 9, equals my a value that I'm trying to solve, times your x value, which x value is negative 1, minus the h value. The h value is negative 3 squared, and then plus your k value, and your k value is 7. So now this equation I could solve for a. So let's simplify inside parentheses first. Negative 1 minus negative 3 minus a negative is plus. Negative 1 plus 3 is 2. Bring down your plus 7. 2 squared is 4, so this is a times 4, which is just 4a. Subtract 7 on both sides, we get 2 equals 4a. And then divide 4 on both sides, we get 2/4, which simplifies to 1/2. So for the vertex form, it would be y equals a times x minus your h value, minus a -3 is +3 squared, and then plus your k value, which is 7. Now, let's say that the question, for whatever reason, asked me for standard form. It didn't. But if it did, then I would just simplify this. Okay, you would simplify. Actually, I could do that with you right now. You would simplify two copies of x plus 3 multiplied together will be x squared plus 6x plus 9. And then you would distribute the 1/2 to all three terms. 1/2 x squared plus 1/2 times 6 is 3x. 1/2 times 9 is 9/2. And then plus 7 I'm going to write as 14/2, so I can combine these two constant terms on the back. So my standard form, if I wanted to write it, would be 1/2 x squared plus the 3x. And then remember, denominator stays the same for your result. And then you just add the top. 9 plus 14 is 23. Alrighty. Let's move on to number 12. So on number 12, we need to find what is the domain and the range of the function. Now, the first thing you need to do is figure out what kind of function this is. Well, it has a highest power of 2, so this is a quadratic function. Quadratic functions are parabolas. So in this parabola, I need to figure out which way is it facing. The a value is positive, so this is a parabola facing up. So the domain, I can already see, is -∞ to +∞. All real numbers. Arrow on the left to arrow on the right. The range is going to be a little bit more difficult because I need to find there is a lowest, right? The range are all the y values for your function. So there is a lowest y value here. So I need to find what is that y value. That will be my lowest point, okay? And then all the way up till at the top we have arrows, so that will go up to +∞. So I just need to figure out what is that y value of the vertex. Now technically, this is vertex form, okay? I could rewrite this in vertex form. It's just that your h value is 0, right? If I were to rewrite this in vertex form, okay, alternatively, of course, you could find the vertex by plugging in first finding h and -b/2a, and then plugging that in to find k. But if you just view this as vertex form, then you save yourself from all that work. The vertex form would be x minus 0 squared minus 8, right? You can see x minus 0 would just be x, so that's how you get x squared, okay? So your vertex is actually x is 0, y is -8. So you could see that y value, the lowest value of the parabola, will be that -8 value. All right, let's move right along to number 13. Actually, let me go back for a second. I wrote these in interval notation, right? Remember, you can always write them in set builder, like as an interval instead. For the domain, it would be all real numbers. And for the range, it would be every y value that is greater than or equal to -8, because you go from the lowest -8 all the way to the highest positive infinity, okay? So you can always write them as interval notation instead. Okay, let's move on to number 13. So on number 13, I need to graph the function and write all of this information, okay? So what I'm going to do is I'm going to find all of the information, okay? And then I could graph the function. Or you could also graph the function first. Since this is in vertex form, it's actually quite easy to graph it, okay? So you can graph it instead, but I'm just going to go ahead and write the key features and then use that to graph is really what I want to do. So the vertex here is in vertex form. So the vertex is easy right at the beginning, is -2, -5, right? And then I know that the domain, because this is a quadratic function, is all real numbers, -∞ to +∞. And this is facing up because the a value, is positive, right? This a value is positive, so it is facing up. So this is an upward facing parabola with this as the vertex, right? So that will be the lowest value is right here, right? So just if I did a quick rough sketch without any other points, which, you know, you need some other points to make it a better sketch, but it will be upward facing parabola with this as the lowest value. So already the range, I could tell right away, right? The lowest y value will be that -5, and then that will go up to positive infinity since it is an upward facing parabola. Let's go ahead and find the y-intercept. Okay, to find the y-intercept, I need to set the x value to be 0. So y is 1/4 times 0 plus 2 squared minus 5. Now 0 plus 2 is 2, right? Remember, we need to do parentheses first. Then exponents, 2 squared is 4. Then multiplication, 4 times 1/4 is 1. And then subtraction, 1 minus 5 is -4. So your y-intercept is -4. Let's go ahead and plot that. And then reflect that over the axis of symmetry, which let's go ahead and just graph that axis of symmetry. Boom, right there. The axis of symmetry is a vertical line, x equals down the x of the vertex, -2. And then reflect that y-intercept so that I can get another point over here. Then I need to find the x-intercepts, okay? For the x-intercepts, I'm going to set the y value to be 0 and then solve for x. So I get 1/4 times x plus 2 squared minus 5. Add 5 to both sides. We get 5 equals 1/4 x plus 2 squared. Then we need to get rid of the 1/4 in front. So let's go ahead and multiply 4 on both sides. 4 times 5 is 20. I'm just going to write that over there. And 4 times 1/4 would just be 1. So we get 20 equals x plus 2 squared. And then I need to get rid of the squared, so I'm going to square root both sides. Remember, when you square root both sides, you do get plus minus. So I have plus minus the square root of 20. Now, square root of 20 can be broken up into square root of 4 times the square root of 5. So this is 2 square root of 5. Over here, the square cancels, and we get x plus 2. Last step to get x by itself is subtract 2 on both sides. So our two x-intercept exact values are -2 plus minus 2 squared 5. Now what I can actually do is I can estimate these values, so I can plot guesstimations on the graph. So with our calculator, we want to do 2 times the square root of 5. And initially your calculator will just give you 2 square root of 5. Go ahead and click the 2 arrows on top of the enter button, and that'll give you an approximation. So 2 square root of 5 is about 4.5. Okay, so we have -2 plus 4.5, which is 2.5. And then we have -2 minus 4.5, which would be -6.5. So +2.5, roughly, and -6.5, roughly. So with all of that, right, I have my sketch. And I'm going to try my best to connect these dots as best as I can. It's actually not looking bad so far. Good enough. Remember to curve at the vertex, guys. Do not give me a V shape, right? V shape, that's absolute value. U shape, parabola, quadratic function. Okay? So, positive interval. Remember what determines if it is a positive interval is the x-axis, right? If it is above the x-axis, that is a positive interval. That's a y value that's positive. If it's below the x-axis, a negative interval. It's below, right? So the x-intercepts help me determine what is the positive interval, okay? So this is a U shape facing up. So notice that this part below is the negative interval. The positive interval are the pieces that are above the x-axis, which would be these two pieces on the side. So the one on the left is from -infinity up until that first x intercept value, which was the negative 6.5, which came from me doing negative 2 minus 2 square root of 5. And then a union starting from the second x-intercept, which is from negative 2 plus 2 square root of 5, all the way till arrow on the right, positive infinity. So that is the positive interval. The increasing interval, that is completely different. Remember, for increasing, decreasing, we look from left to right, which piece is going up, which piece is going down. This is a U-shaped parabola facing up. The vertex is what determines where we shift from decreasing on the left to increasing on the right side. So we need that x value of the vertex. The x value of the vertex is negative 2. So you could see right here, right? From that x value negative 2 till all the way to the right, we are increasing, going up from left to right. And then lastly, restrict the domain so it is invertible. Remember, to restrict the domain so that it is invertible, we just need to use half of the graph. So you could either use the left side of the graph or the right side of the graph. You could either use the decreasing piece or the increasing piece, but not both. So it doesn't matter. You could either pick the right side, x is greater than or equal to negative 2, or you could pick the left side, x is less than or equal to negative 2. One or the other, but not both, okay? I'm going to go with the right side. That's usually what we go with, okay? All right, let's go ahead and move on to number 14, okay? So on number 14, we need to write the function that is graphed below. So to write the function, I need to first figure out, do I have the vertex or not? Remember, the function that you want to write is the easiest one for that type. If you have the vertex, you want to write vertex form first. If you don't have the vertex, then you're going to have to write standard form first. Regardless of whether they ask you for standard form or vertex form, you always want to write the easiest form first, and then we can always convert if we need to, okay? So let's go ahead and take a look here. Well, I have the vertex, so that means I'm going to write the vertex form first, and then I can simplify to get standard form second. So what is the vertex? The vertex is negative 2, 1. That gives me hk. All I need to do now is find a. Now remember, you could potentially use a trick of finding what is the slope 1 unit to the right, but if you look 1 unit to the right, that's not exact. Is that 1/5? Is that 1/4? Is it 1/6? Is it 1/3? Don't know, right? So you have to solve for the a value in that case. So to solve for the a value, we need to pick any other random point on the graph, okay? You can pick this one, any other random point. I'm going to just go ahead and pick this one, negative 4, 2, okay? So this is my random point xy. So I'm going to go ahead and start to write vertex form. Remember that the vertex form is y equals a times x minus h squared plus k. So notice, now that I have h, k, x, y, I could plug that in to my vertex form. I could plug in h, k, and then your x, y. Okay, so that's exactly what I'm going to do. The y value, 2, equals a times the x value, negative 4, minus the h value, negative 2, squared, plus the k value, 1. So again, all I did was plug in my x value, my h value, my k value, and my y value. And now I have an equation of one variable, and I can solve for a. So 2 equals a. Negative 4 minus negative 2. Double negative here is a plus, so negative 4 plus 2 would be negative 2. The negative 2 squared, right, is 4. So that's a times 4, which is 4a. Bring down your plus 1. Subtract 1 on both sides. We get 1 equals 4a. Divide by 4. So a is 1/4. So, it looked about that, right? It looked like maybe like 1/4 of the way through, or maybe 1/3 of the way. It was 1/4. So now I could go ahead and plug that in. Remember, for vertex form, all we need to plug in is a, h, and k. So y equals 1/4 times x minus -2, which will be x plus 2 squared plus 1. And that is the vertex form. To find the standard form, all we got to do is simplify. So let's go ahead and multiply 2 copies of x plus 2 multiplied together will give me x squared plus 4x plus 4. Then we can distribute 1/4 to all 3 terms, which would be 1/4 x squared plus 1/4 times 4 would just be 1x. 1/4 times 4 is 1. And then bring down the plus 1 over here. So my final standard form would be 1/4 x squared plus x. 1 plus 1 is 2. So you see how easy that was to simplify. So if you have the vertex, start with vertex form first. Solve for the a value if you need to. If you could use the trick of 1 unit to the right and you see exactly what that slope is, 1 unit to the right, that's your a value. You could use that trick. Makes it a lot easier, right? And then if you need the standard form, just simplify. All right, let's move on. Number 15, write the following quadratic function in vertex form. Okay, so we need to write this in vertex form. This is a table. Remember that your vertex is the middle of the parabola, okay? I know this is a parabola y. It says quadratic function, okay? So it's a parabola. The middle of your parabola is a vertex. And then to the left and the right of that vertex in the parabola, it will be symmetric, right? So the left and the right side y values are the same. So I need to look for symmetry here. Do I see y values that are symmetric? Yes, right here. Do you see that? Do you see? -1, -1. So that tells me that this point in the middle is my vertex. So I have my vertex right away. So my vertex, HK, is 1, 2. And they asked me to write it in vertex form, so I don't need to even bother writing it in standard form. So all I need now is the a value. Now remember, the a value, right, we can either solve by plugging in, I have a bunch of x and y values here, right? You can plug in a random x and y value and then solve for a, but do you see that we have a point directly 1 unit to the right, right? What's to the right of 1? 1 unit. 2. So we have a point directly 1 unit to the right. So we could actually just use the slope of 1 unit to the right. So 1 unit to the right, the slope here we went down 3. So the a value is actually -3. Okay. If that doesn't logically make sense, again, you can always solve for it. Okay. Let's pick any random x and y value. X, y right here. Okay. Plug it into the vertex form, right? Y value equals a, that we're going to solve for because we don't know it because we didn't see that this is 1 unit to the right, right? A times x minus h squared plus k. Ooh, I forgot to plug in my x right here is 4. And then we can solve for a. So -25 equals 4 minus 1 is 3, right? Then 3 squared is 9. 9 times a would just be 9a. Then we could go ahead and subtract 2 on both sides. So we get -27 equals 9a. And then divide 9 on both sides. We still get a is -3. Okay. So whether you can, be a little bit, more attentive to the problem and realize, wow, there's a much easier way to do this. Or you can go through and, do the work if you really want to. So y equals, but remember, we always want to do things the quickest possible, right? So always take a look at what you got going on because a lot of times I give you guys things that are easy if you can see and you know what you're doing, okay? So our function in vertex form, y equals the a value times x minus the h value, 1 squared plus the k value, 2. All right. Let's go ahead and move on to number 16. All right, number 16, we have another graph one with a bunch of key features. This one, we start with standard form. Now, vertex form, you have the vertex to begin with, right? Standard form, you have the y-intercept to begin with. Remember, the y-intercept is the c value. So the y-intercept is giving to you right away, -3. To find the vertex, we could do two things. We could either complete the square to get the vertex form, or we can use that formula, right? Let's go ahead and use the formula. Okay, so the h value will be -b over 2 times the a value, -3/4. All right, so we got some fractions to deal with. So we got -1 over 2 times -3 is -6 over 4. A negative divided by a negative is a positive, and we have 1 divided by 6/4, right? Dividing any number is the same thing as multiplying the reciprocal. So this is 1 times 4 over 6, which would of course just be 4 over 6, and 4 over 6 was simplified to 2/3. So the x value of the vertex is 2/3. Now we need to find the y value. How do we find the y value? Well, we plug it in to the function. So -3/4 times 2/3 squared plus 1 times 2/3 minus 3. Again, to save time, highly suggest you guys just use your calculator, right? And then like I showed you up here, you could just plug the whole thing in. Negative fraction 3 over 4 parentheses 2/3 parentheses squared, all of that, okay? I already did it to save a little bit of time right now, but if you plug this all into your calculator, we end up with -8/3. Alternatively, of course, you should be able to do it by hand, but on the test, we want to save time, so just use your calculator because you have that power. Okay, let's go ahead and estimate these two values, okay? 2/3 is 0.6, just for graphing purposes, okay? So 2/3 is 0.6 repeating, which will be about 0.7, and then -8 divided by 3 would be -2.7, 2.6 repeating, so -2.7-ish. So we have positive 0.7, so a little more than halfway, and then -2.7, a little bit more than halfway. So roughly about there. It's just a sketch. And then we need to go ahead and we can graph the y-intercept, okay? We can graph the axis of symmetry. That's going to help us visualize the reflection over the axis of symmetry, right? We have the y-intercept already as -3. And then if we reflect that over, we're about, 2/3 of the way this way. So if we go 2/3 of the way this way, boom, reflected right there. And then let's go ahead and find the x-intercepts. Now, when I find the x-intercepts, it is logical that we are going to get imaginary numbers. How do you know that, Ms. Cabrera? You're a genius. No. Look, this parabola is facing down, right? The a value is negative. Makes a lot of sense too, because you have the vertex up here and then your y value is below. So your parabola looks something like this. Does it ever cross the x-axis, the real x-axis? No. So automatically, I already know that these x-intercepts are going to be imaginary, okay? But let's go ahead and solve for them, okay? So x equals -b. I'm not even going to bother trying to factor because you can only factor if you have real numbers, right? So factoring is not going to work out. So I'm just going to use the quadratic formula. Remember, quadratic formula is -b plus minus the square root of your b value squared minus 4 times your a value times your c value. This is all going over 2 times your a value. Okay. Let's go ahead and simplify by terms, okay? So 1 squared is 1. -4 times -3/4. -4 divided by -4 is -1. And then -1 times -3 is +3. +3 times -3 is -9. Hopefully you followed me with that one. And then 2 times -3/4 will be -6/4, which would simplify to -3/2. -3/2. Okay. 1 minus 9 is, of course, -8. And then I need to simplify that. The square root of -8 would simplify I'll do this here on the side. The square root of negative 8 can be broken up into the square root of negative 1 times 4 times 2, right? Negative 1 times 4 times 2 is negative 8. The square root of negative 1 is I, the square root of 4 is 2, and then the square root of 2 would just stay square root of 2. So the square root of negative 8 is 2i square root of 2. Now, dividing any number is the same thing as multiplying the reciprocal, right? So negative divided by a negative would be a positive, and 1 divided by 3 over 2 is the same thing as 1 times 2 over 3. 1 times 2 over 3 would just be 2 over 3. In the denominator, right, we're dividing by negative 3 over 2. So that negative 3 over 2 is actually going to change this plus minus to be a minus plus, because we're dividing the positive by a negative will give us a negative. Dividing the negative by a negative will give us a positive. It's still, you know, both minus and plus answers, but, you know, it just technically switches them. Now, again, dividing any number is the same thing as multiplying the reciprocal. So dividing 3 over 2 is the same thing as multiplying 2/3. So I'm basically multiplying this numerator by 2/3. If I multiply by 2/3, then 2i times 2 is 4i. So my final imaginary solution for the x-intercept is 2/3. Minus plus, but it's both answers, so plus minus is fine. 4i square root of 2 all over 3. And those are your x-intercepts. They're imaginary, so we can't graph them. The x-symmetry is the line. X equals down the x of the vertex, which is 2/3. Always a line, guys. Always a line. Your range is, lowest y value is on arrows at the bottom, so negative infinity, all the way up to the highest point, which is the maximum, which is the y value of the vertex, 2/3. And then your domain, arrows left and right, is all real numbers, negative infinity to positive infinity. Okay, what do we have remaining here? Increasing interval. Okay, what part of the graph is going up from left to right? It's a parabola facing down, right? So the left side of the graph is increasing, the right side of the graph is decreasing. So this left side is the increasing piece from arrow on the left, negative infinity, all the way up to the x value of the vertex, which is 2/3. Negative interval. Now, what part of the graph is below the x-axis? What part of the graph has negative y values? The entire thing. There's no parts of the parabola that are above, right? So the entire thing, negative infinity to positive infinity, is below the x-axis, has a negative y value. And then lastly, restrict the domain so it's invertible. Remember, we use the left or the right side of the graph. You can use any side. I'm just going to go ahead and use the right side. That's what I usually do. The right side of the graph from the vertex would be x is greater than or equal to 2/3. Okay, we can also write it in interval notation if you wanted to, right from 2/3 till infinity. Everything to the right of 2/3. If you wanted to use the left side, you can. You would just have it as x is less than or equal to 2/3. And if you wanted to write that in interval notation, it would be negative infinity up to 2/3. Okie dokie. That's number 16. Let's move on to number 17. Okay, so on number 17, we need to determine the end behavior of the function. Okay, end behavior are the ends. So you have what kind of function? You have a parabola, right? You have a quadratic, which is a parabola. What direction is that parabola facing? It is facing up. It's an upward facing parabola. So on the ends, remember, are just the ends. You don't need anything else. The ends are just the ends. So on the right side, as x approaches positive infinity, where is this h of x function facing? On the right side, look at the arrow. On the right side, as we go more and more to the right, that will continue to go more and more positive. The y value will continue to get more and more positive. On the left side of the parabola, right, as x gets more and more negative, the y value is also going up to positive infinity. As the x value gets more and more negative, the y value is still getting more and more positive. Both ends are going up to positive infinity. Okay, that was easy. Moving on to number 18. Now, number 18, we need to find the equation. Okay, so this is an equation question. Remember, what you want to look at is, do I have the vertex? If you have the vertex, write vertex form first. If you don't have the vertex, you have to write standard form first. Looking at this one, the vertex. Do you have any idea what that is? Because I don't, right? So we're going to have to write standard form first and then write vertex form second. Now, in order to write standard form first, remember, for standard form, the standard form is y equals ax squared plus bx plus c, okay? So what we need to fill in for standard form is a, b, and c. Now, the c value of standard form is just the y-intercept. Do we at least have that? Yes, the y-intercept is -2. So c is -2, okay? Now, I still don't know what a is, and I don't know what b is, okay? So what I'm going to have to do is write a system of equations, okay? One equation will be with one random point, any random point on the graph, okay? Let's go ahead and pick this one right here, which is the point -2, 0. And then another random point. Any other random point on the graph will work, okay? You just got to find one. Find one that's going through the graph. Any point that's going through the graph. You can't use your y-intercept because you're going to use that as c, right? So you can't use that. Any other point on the graph, I see one right here. 1, 6. So this, I'll use this one for equation 1, and then this one for equation 2. Now again, these random x point is xy. So we're going to plug this into the standard form. Y equals a, I don't know, times the x value, here for the first equation will be -2 squared, plus the b value, which I don't know, times the x value, again for this first point is -2, plus the c value. The c value is -2 because that is the y-intercept. For your second equation, you're going to use your second point, okay? So now this is the xy that I'm going to use. And again, standard form. So the y value here on the second equation is 6 equals a times the x value on the second equation is 1 squared, plus b times the x value, again, in this second equation is 1, plus the y-intercept. The y-intercept for the graph is obviously still -2. Then we have to simplify. Once we simplify, that'll give us a system with 2 unknowns, and then we can solve for that. So let's go ahead and add 2 on both sides for the first equation. 0 plus 2 is 2. And then -2 squared is 4. 4 times a is 4a. -2 times b is -2b. On the second equation, let's go ahead and do the same thing and add 2 just to get all the constants like consolidated and together. So if we add 2, 6 plus 2 is 8. 1 squared is 1, so 1 times a is just a. 1 times b is b, when 1 times b is just b, so plus b. Okay, so now I have a system. Now I can solve this. Okay, I can solve this for the a and the b values. Now I'm going to use elimination as a method for solving. So I'm going to go ahead and multiply the second equation by 2. So that'll give me 16 equals 2a plus 2b. Cross that out, and then I can go ahead and add these two together. -2b plus 2b will cancel, which is awesome because now I'm going to be able to solve for a. 4a plus 2a is 6a, and 2 plus 16 is 18. Divide 6 on both sides. We already have our a value of 3. So now we have our a value, we have our c value. All we have to do is take a, plug it in to one of the 2 equations to solve for b. I'm just going to pick the top one. So 2 equals 4 times the a value, 3, minus 2b, and I can solve for b. 4 times 3 is 12, so 2 equals 12 minus 2b. Then we can subtract 12 on both sides, so we get -10 equals -2b. Divide by -2 on both sides, b is 5. So I have my a value, I have my b value, I have my c value, which means I could write standard form. So let's go ahead and write that standard form. Y equals a value 3 times x squared plus the v value 5 times x plus the c value -2. And that is your standard form. Okay, now is the tricky part. We need to write the vertex form. Writing the vertex form is going to be a little bit of a struggle because we need to do one of 2 things. Either we need to use this formula to find h using -b over 2a and then plug it in to find k, and then the a value is just obviously the same a value from here, or are we going to complete the square? I'm just going to show you completing the square. I usually find that easier, okay? But you do whatever you think is best for you and whatever you think is quickest for you. To complete the square, I do need to separate the back term, right? And factor out the coefficient from the first two terms. So I end up with x squared, and then 5 divided by 3 does not give me a whole number, which is a little bit sad. So we have 5 over 3. So that is the b value. Remember, for completing the square, we're going to take that b value, we're going to divide it by 2, which is the same thing as multiplying the reciprocal 1/2 and then squaring it. So we have 5 over 6 squared, which will be 25 over 36. So that's what we need to add here. We need to add 25 over 36. Now when I add 25 over 36, I need to then balance and subtract on the back. But I didn't actually add 25 over 36 because I added that inside of the parentheses. And outside of the parentheses, I have a coefficient. So that's really 25 over 36 times 3. And 3 divided by 36, right, will be 1 over 12. So this is 25 over 12. So I really added 25 over 12. So I need to subtract 25 over 12 to the back. So now all I have to do is factor this. Okay, which x squared plus 5 over 3x plus 25 over 36 would factor into x plus 5 over 6 squared. Okay, you can always check 5 over 6 times 5 over 6, 25 over 36, good. 5 over 6 plus 5 over 6, 5 over 3, good. And then on the back, we just need to simplify negative 2 minus 25 over 12. If we think about negative 2 as negative 2 over 1, right? We need the denominator to be the same. So it's really negative 24 over 12. And so the negative 24 minus 25 is negative 49. And the denominator of 12 stays. So this would be my vertex 1. Okie dokie. That was a lot of hard work. Let's go ahead and move on to number 19. So on number 19, we need to determine whether the function is even, odd, or neither. All right, let's go ahead and do that. Now, I could do this algebraically. I could do this graphically. Or it doesn't tell me to do anything, so I could use a trick, right? This quadratic function, if it has a b value, then it is not. The vertex is not on the y-axis. I also can tell that this is neither because I have an even power and I have an odd power, so it's neither, okay? But as well, you know, this is a parabola. The parabola has to be on the y-axis in order for it to have y-axis symmetry, and this is not on the y-axis because I have a b value, so it is neither, okay? All right, so let's go ahead and move on to number 20. All right, for number 20, we need to restrict the domain so that the quadratic function is invertible. I know that the quadratic function is not invertible because no quadratic function is ever invertible. Whether the parabola is facing up, like this one, or down, it would never pass the horizontal line test, okay? So I need to restrict it, okay? What I need to restrict that is the x value of the vertex. Because remember, we want to use either the right side or the left side of the parabola. Either you want to use the decreasing piece or the increasing piece, not both. Half of the parabola only. Now the vertex, nice, this is vertex form, so we have the vertex right away, is at 4, negative 3. And so the x value of the vertex is at 4. So we want to restrict, we can use the right side or the left side. I'm going to go with the right side. I'm going to use the right side of the graph, disregard the left completely, so I'm going to use the right side, which is the positive side. So x is greater than or equal to 4. Now that I have that restriction, I can go ahead and solve for the equation. I'm going to go ahead and find the inverse by switching the x and the y value. So the y value becomes x. The x value becomes y, and then I need to solve for y. So I'm going to go ahead and add 3 on both sides. So I have x plus 3 equals y minus 4 squared. Then I could go ahead and get rid of the squared by square rooting both sides. And remember, when you square root both sides, you do get plus minus. However, the minus side we're not using, right? We're only going to use the plus side. So we're going to disregard the minus sign. We're just going to keep the plus side only, so that our inverse is actually a function. If not, when we do the inverse, it'll end up like a sideways parabola like this, and then it won't be a function, okay? So we want to use the right side only, which will give us only the top half, right, the positive square root, and then that will be, in fact, the function because it will pass the vertical line test. Okay, so we're keeping the plus, and then on the right-hand side, the squared cancels, so we have y minus 4. So the last step would just be to add 4 on both sides, so we're adding 4 to both sides. So my final answer, the inverse function, the inverse of f, is positive 4 plus the square root of x plus 3. Now, if we chose instead to use the left side, x is less than or equal to 4, this would just change the answer as we would use the minus side. So we would have the inverse be 4 minus the square root of x plus 3. Okay, moving right along, let's take a look at number 21. So on number 21, it says that a baseball is thrown vertically into the air. Its height with respect to time can be described by this quadratic function right here, okay? I don't know why this is not in standard form, so I'm just gonna go ahead and rewrite it in standard form. I don't like it not being in standard form. It's not really like a problem with the question, but just the way that, to view the question is easier to view it this way. H is the height in meters, T is the time in seconds. What is the maximum height of the ball? So imagine, this is a parabola, right, facing down because we do have a negative a value. So we're just trying to find that maximum height of the ball, which will be the maximum value of the parabola, which would be the y value of the vertex. So I could easily find this by solving for the x value of the vertex first, okay, using the formula negative b over 2 times a. And I'm just going to use a calculator to solve for that. This will be a negative and the denominator will be a negative, so the entire thing will be a positive. So we have 16 divided by 2 times 4.9, I believe is 9.8, but I'm just going to write it in here just to make my life a little bit easier. So 16 divided by 9.8 will give me about 1.6. Okay. Now it didn't ask me to round in the problem, but I'm just going to round because, of course, the height, we want it to be like a number, like an estimated number. So I'm just going to round to the nearest tenth and use roughly about 1.6. So that will be the x value. That is not the maximum, okay? That is the time, t, that it reaches the maximum. We need the height, h, the output, right, h of t, for what is that maximum value. So we need the y value, not the x value. The x value will give me the time that it takes to reach the maximum height. We need the actual height. We need the maximum height. So the maximum height, we need to find, the y value. So I'm going to plug in 1.6 into the question. So negative 4.9 times 1.6 squared plus 16 times 1.6 plus 2. And again, you can just use your calculator to plug all of that in to get the calculator to do it for you quickly. So I'll just go ahead and show you that quickly. So negative 4.9, parentheses, 1.6, close the parentheses, a power of 2, go to the right to get out of the power, plus 16 times 1.6, close the parentheses, plus 2. Hit enter. All of that is about 15.05, So it will be about 15.1. So my height is about 15.1, or I could round it to the nearest whole number even, right? It didn't ask me to round, so I could really round to whatever I want to. So I could go with a max height of 15 meters. I know it's meters 2 ways. Number 1, remember your height model. Your gravity is negative 4.9 if you're using meters. It's negative 4.9, so clearly we're using meters. The other way is it says it right in the question, right? All right, let's move on to number 22. So on number 22, we have George and Charles are both started a toy business the same year. The total amount of money in the businesses are given by the function g of x for George and then in the graph for Charles, okay? So g of x is George, so this is George, and then this is for Charles. Which one invested the most money at the beginning of the business? Okay, so what is the money at the beginning of the business? The money at the beginning of the business is the initial amount, which would be the amount of money at time 0, okay? So at the beginning, at 0 years, what is that money? What is the y value is the money, time t is the x value, right? So For Charles, we could just see it right here, right? 11, 12, 13, 14, 15. Wait. 10, 11, 12, 13, 14, 15. Okay, I was just making sure that was correct. So his amount of money is 12 at the beginning. So 12 at the beginning, initially. Now for George, we don't have an equation. I'm sorry, we don't have a graph. We have an equation. So we need to plug in something to find that y value. So what are we going to plug in? Well, the initial money is at time 0, right? So we need to plug in for George 0 for x, and that will give us the amount of money that he initially put in. Now, I could solve for this and, do all the math, but the y-intercept at time 0 in standard form is just the c value. So yeah, I could do 0 squared is 0, 0 times -5 is 0, 45 times 0 is 0, 0 plus 0 plus 11 is 11. But that just took me like 30 seconds that I could have saved, right? Whereas if I know that from standard form, the y-intercept is the c value, there you go, I already know that for George, that is 11. So which one invested the most money at the beginning of the business? Charles. He invested 12, George invested 11. So by how much money did he invest more? By $1. All right, let's move on to number 23. So on 23, we need to find the intercepts of the quadratic function. Okay, intercepts. So again, we are finding both x and y intercepts. Okay, it didn't specify just x or y, so we're finding both. Okay, so let's start with the x-intercepts. To find the x-intercepts, we're going to set the y value to be 0 and then solve for x. Okay, so I'm going to go ahead and set the y value, the output g of x, to be 0. And then I need to solve for the x value. Okay, so I'm going to go ahead and first get rid of the fraction in front by multiplying the reciprocal, 3 over 2. But 3 over 2 times 0 will just keep 0 on the left-hand side. Then I need to go ahead and get rid of the squared by square rooting. Remember, when you square root both sides, your square root is plus minus, so we get plus minus 0. But positive 0 versus negative 0 is really just 0. And then subtract 3 on both sides, so our x-intercept is negative 3. Again, you can write it like this, or you can write it as an ordered pair, x-intercept negative 3, of course the y value is 0. You could write it either way. Just a number, or you can write it as an ordered pair. Now let's go ahead and find the y-intercepts. For finding the y-intercept, we're going to set the x value to be 0 and then solve for y. So we're finding g of 0. So 0 plus 3 is 3. 2/3 times 3 squared. Do the exponent first. 3 squared is 9. 2/3 times 9. If we cross cancel, 2 times 3 is 6. Or we could write it as an ordered pair. X value 0, y value 6. So you just had one y-intercept. Any function will always have one y-intercept. The x-intercept was negative 3, 0. This is a quadratic, so side note, you will only have one x-intercept when the x-intercept is actually the vertex. So this is a parabola facing up, and the vertex is the x-intercept. And I know that because there's only one x-intercept. And the only way that you can get only one x-intercept is if that x-intercept was actually the vertex. Any other way, if like the vertex was down here, then you could see that we would cross the x-axis twice. All right. Let's go ahead and move on to 24. So on number 24, I need to go ahead and graph the quadratic equation. Now for graphing, you are going to want key features, right? So I need the vertex, very, very important, and then at least 2 other points, okay? So let's go ahead and find the vertex for this one. And what I'm going to do is I'm just going to get the vertex form, because the vertex form is going to give me the vertex, and it'll give me the a value as well, which I could use the a value to do the slope 1 unit to the right. So let's go ahead and just complete the square. So I'm going to factor out negative from both terms and separate the back term. Then I'm going to take that b value, I'm going to divide it by 2, and I'm going to square it. So I get negative 2 squared, which is 4. Guys, remember, do not mix up these two formulas, b over 2 squared, which is how you complete the square, and the formula for the x value of the vertex, which is negative b over 2a. Okay, I know that might seem similar to you, but make sure that you make that difference. This is for the x value of the vertex. This is for completing the square. So for completing the square, I need to add 4 here. Now that 4 is not actually a 4. It's a 4 times a negative 1. So I actually subtracted 4. So what I need to do to balance is add 4 on the back. So my final vertex form is x minus 2 squared plus 1. So my vertex is negative 2, 1. Of course, alternatively, I could have used this formula to find the x and then plug x in to find the y value. But the point is the vertex is negative 2, 1. Then, I just realized I made a very silly mistake. So be careful with this, guys. Remember the x is always opposite, right? It's x minus h. So h is actually just positive 2, okay? So 2, 1 is my vertex, excuse me. Then I need another point, okay? Now I could easily see another point here because the y-intercept in standard form is negative 3. So that gives me another point. And then I could just reflect that over a axis of symmetry, right? For a third point. Now if you want more points, you can, but 3 points is good enough for a sketch. Go ahead and connect those 3 dots. Remember to curve at the vertex, guys. Do not give me a V shape. V shape is absolute value. This is a quadratic, right? Parabola. So there you go. That is the sketch. Number 25, let's go ahead and graph this one as well. This one they gave it to us in vertex form first. So now I can see the vertex is negative 2, 1. And then I need another point. Now I could use the x-intercepts, but usually that's a little bit more complicated because I got to do some like more calculations. Plugging in x is 0 is easier, so let's go ahead and find the y-intercept. So 1/3 times 0 plus 2 squared plus 1. So I'm finding the y-intercept here. 0 plus 2 is 2, 2 squared is 4, so this is 1/3 times 4 plus 1. 1/3 times 4 will be 4/3, and 1 is 3 over 3, so this is 7/3. 7/3 is roughly 2 and 1/3, so it's a little higher than 2. And then I could reflect that over an axis of symmetry for a third point. That's good enough for a rough sketch. There we go. And we can always kind of confirm, right, that we didn't do anything super crazily wrong because the A value is positive, so this should be facing up. Over here on number 24, the A value is negative, so it should have been facing down. Everything kind of connects together. All right, so let's move on to 26. So on number 26, we need to find the equation of the quadratic function that will pass through this point, and this point. Ooh, okay. Do we have any clue about having the vertex? No. Because there is no, like, symmetry here with the y values, right? If the y value, like, one was this, one was that, and it was in between exactly 2 other ones, then maybe. But no clue about what's the vertex. No clue about what's the y-intercept. So, worst case scenario here, right? We cannot write the vertex form to start because we don't have the vertex. So we need to write the standard form. So standard form is y equals ax squared plus bx plus c, okay? Now, if I had the y-intercept, then at least I could plug in that so that then I only had 2 unknowns, so then I only needed 2 equations. But that's not the case. This is 3 unknowns, so we're going to have to use all 3 points. X, y will give me equation 1. Then this x, y will give me equation 2. And then this x, y will give me equation 3. So let's go ahead and do that. Starting with the first one, y equals a times x squared plus b times x plus c. Your second point, y equals a times x squared plus b times x plus c. And then your third point, y equals a times x squared plus b times x plus c. Okay. Let's go ahead and simplify these 3, and then we have a 3 by 3. So, and negative 11 equals negative 2 squared is 4. 4 times a is just 4a. Negative 2 times b is negative 2b. And then c, of course, is just c. negative 12 equals, negative 1 squared is 1. A times 1 is A. Negative 1 times B is negative B. And then plus C, of course, is just plus C. And then the third one, 16 equals 1 squared is 1. A times 1 is A. B times 1 is B. And C, of course, is just C. Okay. So let's go ahead and group the first two equations and group the last two equations. And then we're just going to subtract them to cancel out C. And then we're going to have a 2 by 2. So grouping the first two, we have negative 11 equals 4A minus 2B plus C. And then the second equation, negative 12 equals A minus B plus C. So that's the first two groups. Subtract these two together to cancel out C. C minus C would cancel. Negative 11 minus a negative 12. Negative 11 plus 12 is 1. 4A minus A is 3A. Negative 2B minus negative B minus a negative is really a plus. So negative 2B plus B is negative 1B. C minus C cancels. In the second grouping, right, we have the middle equation, negative 2 equals A minus B plus C. And then the third equation, 16 equals A plus B plus C. We need to go ahead and subtract these two as well. So again, we could do C minus C cancels. Negative 12 minus 16 is negative 28. And then A minus A actually cancels. Negative B minus B is negative 2B. I got a little excited there because now we already have B. That's great. Divide negative 2 on both sides. We actually get B is 14. So if B is 14, let's go ahead and plug that in right here into B. So 1 equals 3A minus 1 times 14. Of course, 1 times 14 is just 14. If we add 14 to both sides, then we get 15 equals 3A, and then divide 3 on both sides, we get A is 5. So we have A, we have B. Now let's go ahead and plug those two in into this equation. You could pick any of them, but I'm just going to pick the bottom one, just because it's right there. So A is 5, B is 14, and then we need to solve for the last one, C. 5 plus 14 is 19, so 16 equals 19C. 19 plus C, excuse me. And then subtract 19 on both sides, we get C is 3. Negative 3. So we have A, we have B, we have C. We can write the standard form. So the standard form is y equals ax squared plus bx, and then plus negative 3 will be minus 3. So this is the standard form. Now, if I did want to write it as vertex form, I would have to complete the square, or use that other trick to find hk, and then use a right from standard form. But they didn't ask me for that. They didn't ask me for vertex form. They just asked me to write the equation. This is an equation. It doesn't specify a specific form, so this is perfectly fine. Moving right along to 27. So on number 27, we need to write the quadratic function in vertex form. Okay, so we're just converting this from standard form to vertex form. To get vertex form, we can go ahead and complete the square. So I'm going to go ahead and factor out. Actually, you know what? Let me show you guys doing this in the other way. Let's use the trick, okay? So for the trick way to do it, which is not really a trick, is just finding the h value by using the formula negative b over 2 times a. So negative 13 is positive 13, 2 times 5 is 10, so h is 13 over 10. And then you could plug that in to find k. So 5 times 13 over 10 squared minus 13 times 13 over 10 plus 6. And then simplify, again, you can use your calculator just to save you time on that. If you simplify the whole thing, we end up with negative 49 over 20. So you got h, you have k, and then you can grab a right from the a from standard form. A in vertex form and a in standard form is the same. So your vertex form would be y equals, well, actually they're using f of x here, so let's just use f of x for our vertex form as well, equals a, 5, times x minus the h value, 13 over 10, squared, plus the k value, which k value is negative 49 over 20. So you could use this instead of completing the square if you want to. All right. 28. So solve each of these systems below. Okay, so let's go ahead and solve this one. Now remember that we want to use substitution is really the easiest for solving these systems. So let's go ahead and plug in 2x into the y value here. Okay, so we have x squared plus 2x squared minus 4x equals 9. Okay, because y was already isolated. Now 2x squared is 4x squared, so we have x squared plus 4x squared minus 4x equals 9. We're going to have a quadratic, so we need to have equals 0, so I'm going to subtract 9 on both sides. So I end up with a 1x squared plus 4x squared is 5x squared minus 4x minus 9 equals 0. And then we could try to go ahead and factor for solving, right? So I could go ahead and rainbow over, multiplies to negative 45, adds to negative 4 would be 9 and 5, right? 5 times negative 9, 5 plus negative 9. Remember, if the coefficient is not 1, we need to bring down the first term, bring down your back term, and then go ahead and split the middle into positive 5x minus 9x. Grouping the first two, we could factor out 5x, which leaves us with x plus 1. Grouping the last two, we could factor out negative 9, which also leaves us with x plus 1. Remember, as long as you did the rest of the math right, then those two binomials should be the same. And then you could factor out the x plus 1, leaving you with 5x minus 9. Now, these two multiplied together have to equal 0. So if x plus 1 equals 0, we get the solution x equals negative 1. If 5x minus 9 equals 0, we get the solution x equals 9 over 5, because we would add 9 and then divide 5. Now, those are just the x values, right? This is a system, so I need the ordered pair for the solution. So those are only the x values. I need to find the matching y values. Now, of course, plugging it into this quadratic is going to be a little bit more complex. Why do all of that? Let's go ahead and plug it into the linear. So y value is 2 times the x value. So for negative 1, we get negative 2 output. And then y equals 2 times the x value. So for 9/5, we get 18/5. And those are my two solutions. These are the 2 points where the linear function and the quadratic function will intersect. Actually, this is not a quadratic function because both are squared. That's actually a circle. But anyhow, moving right along to part B. On part B, we have some vertex forms. You know what we can do? Let's go ahead and subtract 1 on both sides here to get y by itself. And then we can go ahead and take that and plug it in for y here. Why not? So we're going to go ahead and replace this whole thing in for the y value right here. So we have x plus 3 squared minus 1 minus 7 equals negative x minus 1 squared. And there we go. So now let's go ahead and simplify. Negative 1 minus 7 is negative 8, right? And we can also take 2 copies of this, multiply it together. So we have x squared plus 6x plus 9. If I take 2 copies of x plus 3, multiply together, will give me that. Bring down the negative 8. And then minus 2 copies of this multiply together will be x squared minus 2x plus 1. If I take 2 copies of x minus 1 and multiply it with each other. And then I can go ahead and distribute the negative 1. And this doesn't simplify. That 1, you know, if you distribute it, it's just the same thing. So 9 minus 8 is 1. So I have x squared plus 6x plus 1 equal to negative x squared plus 2x minus 1. Let's go ahead and get everything to one side to see what we got going on. So let's add x squared on both sides, which will give me x squared plus x squared is 2x squared. Then subtract 2x on both sides, which would give me 6x minus 2x is positive 4x. And then add 1 to both sides. 1 plus 1 is 2. And so then I could try to factor to solve this one, probably the best. So let's go ahead and factor out the GCF of 2 first, would make my life a little bit easier. So if I factor that out, I get x squared plus 2x plus 1. And actually, I don't know if you noticed this or not, but this is a perfect square trinomial, right? 1 times 1 is 1, 1 plus 1 is 2. So that will actually factor into x plus 1 squared. And then now I can solve. So let's go ahead and divide by 2 on both sides. So we get x plus 1 squared equals 0. Square root both sides. We get x plus 1 equals, remember when we square root both sides, the number results is plus minus, but we have plus minus 0, so that's technically just 0. And then minus 1, so our final solution is just -1. So we only have one intersection point here. We still do need the y value for that intersection point for the system, and I could go ahead and plug that into either one of the two equations. I'm going to go ahead and plug it into the one at the bottom, which is y minus 7 equals negative. So y minus 7 equals negative x minus 1 squared. So simplifying inside the parentheses first, -1 minus 1 is -2. And then exponents, right, before multiplication, before multiplying the -1. So -2 squared is 4. -1 times 4 is -4. So we have y minus 7 equals -4. And then adding 7 to both sides, we get y equals 3. So that is our one intersection point. All right. Let's move right along to number 29. So on 29, we're going to consider this function. If q of x is p of x plus 3 minus 3, what is the correct equation for q of x? So we need to just write the equation for q of x. So this is not the actual equation for q of x. This is the equation of the transformation, right? This is just the equation that represents the transformation. So I need to write the actual equation for q of x. So let's go ahead and write q of x is going to be p of x. Now what is p of x? P of x is input plus 3 squared minus 2. Okay. Now it's q of x is not just p of x. It's p of x with transformations happening. So on the inside in the input, instead of just x, it's x plus 3. And then on the outside, to the output, right, we need a minus 3 on the outside. So q of x, if we just simplify, and we started with vertex form, so we can leave it in vertex form, would be x plus 6 squared minus 5. All right, let's do another example. Number 30. So number 30, very similar question. It's asking the same thing, but obviously we have a different equation, a different transformation happening. So again, for q of x, we're going to use the function p of x, right? But that function p of x is not just p of x, right? But let's go ahead and write it with a blank. So p of x is input plus 3 squared minus 2. Now, what's happening to p of x? On the inside with x, the input is just x. And then on the outsides, I need to multiply by a -2 and add 5, okay? Now, I need to simplify this, right? So I need to multiply the -2 to both the first term, which has a coefficient of 1, and to the second term. So this will be -2 times 1, which is -2. And then -2 times -2, which is +4. Bring down the plus 5. Final simplification, q of x equals -2, x plus 3 squared, plus 9. And again, we started with vertex form, so we can leave it in vertex form. We do not have to simplify to standard, unless you really, really want to, which I don't know why you do more work than you need to. All right, last question. A function is defined as f of x is invertible for all x that is greater than or equal to a. What is that a value? So we have a parabola. This is an upward facing parabola because the a value is positive. All that they're saying is this is going to be invertible for some x values greater than or equal to a. That a value is the vertex, right? The x value of the vertex, because we only want to use half of the graph. In this case, they're saying to use the right side, right? When x is greater than or equal to this a value, right? So you're using the right side. But the question is really just asking, what is that A value? That A value would be the X value of the vertex, which is really H. So we need to find H. Peasy, easy peasy, lemon squeezy. We can use the formula from standard form to find H is negative B value over 2 times the A value. So it's really negative 14 over 2, which is just negative 7. So the A value is negative 7, right? So this function is invertible for all X values greater than or equal to negative 7. And that is the review. All right, remember that I am holding a study session if you guys need any help until 4, and I will see you guys in another video. Bye.